Hi everyone, once again I'm back to teach you some mathematics online. This is going to be our fifth lecture in integration, and today we want to discuss something so important. Remember, in lesson 4 we have discussed about products and the quotients of functions and derivatives, and we saw how they're integrated. So in the fifth lesson, let's see what is coming ahead. Friends, we have discussed the integration of a product or a quotient of a function and its derivative. But there are particular situations where you are given an integral and then it's not a function and a derivative. So what do we do about such? Okay, we need to develop some concept that integrates such functions. For example, if you are given integral of x squared times natural logarithm of x by dx, you discover x squared is not a derivative of natural logarithm of x, and the natural logarithm of x is neither a derivative of x squared. So in such a situation, we have to integrate it by parts. So let's see what is involved in integration by parts. If we are to integrate by parts, then we have to go back to differentiation of a product of two functions of x, and we develop the method from the formula of product rule. So we know that, okay, we know that the derivative, if you differentiate a function, a product of two functions, okay, u and v, where u and v are functions of x, you will have u dv by dx plus v du by dx, and this is what we call the product rule. Okay, you have learned about this in differentiation, and we call this the product rule. This the product rule in differentiation. So we want to develop the method of integrating a product of two functions from the product rule. Okay, d by dx of uv, okay, is equal to u dv by dx plus v du by dx. Okay, now we want to integrate everywhere with respect to x, with respect to x, with respect to x. Okay, now this part has two operations. There is this, which shows we are differentiating a function, and then this combination shows that we are integrating. So integration and differentiation, they are exactly equal in magnitude but opposite in direction. Okay, if one is a forward drive, then the other one is a reverse drive, and they are exactly equal. So when you are integrating and differentiating at the same time, you end up with the function uv. Okay, uv will be equal to the integral of u dv by dx with respect to x plus the integral of v du by dx with respect to x. So what we do, we make this the subject. Okay, so the integral of u dv by dx with respect to x, okay, will be equal to uv minus the integral of v du by dx with respect to x. Okay, dear friends, this is going to be the method, or this is going to be the formula that we shall use to integrate a product of two functions. Okay, yeah, one function is going to be u, and then the other function is going to be dv by dx. So we integrate a product by use of this formula. Let's see how we go about this. Okay, so this formula is really going to be very useful when you're integrating a product of two functions. Let us write it again. Okay, let me change the color and have integral of u times dv by dx with respect to x is gonna be uv minus the integral of v du by dx with respect to x. Okay, now let's go back to this example. Okay, let me grab this first of all. Let's talk about this example. That we mentioned at the start of this discussion. We have x squared times natural logarithm of x by dx. Okay, so one function, this is a product of two. We have x squared and the natural logarithm of x by dx. Okay, so one function is going to be u, and then the other function is going to be dv by dx. But the choice of u here is dictated by some rules. Let me first integrate this, then I will write for you a list, okay, or where you can be guided to make a selection of which function is u and which function is dv by dx. Okay, from dv dx we find the function v. Okay, that means we are going to integrate to get v, but u will always be a function here, and you can always tell which function is u. So let u equals to natural logarithm of x. So du by dx is equal to 1 over x. Oh, sorry about that. We have learned to differentiate natural logarithm of x, and this is just 1 over x. So this is 1. Oh, what is this? There's a problem somewhere. Something I don't understand. Okay, this is 1 over x. Okay, so du dx is equal to 1 over x. Then also let dv by dx is equal to x squared. Okay, so dv is equal to x squared by dx. Always to find v, we shall need to integrate. V is equal to x cubed over 3. Don't add a constant of integration because we are still moving on with this integral. So now let's integrate. Let's feed in the function. So the integral of x squared times natural logarithm of x by dx now changes to, let's make the substitutions. U is natural logarithm of x, and v is x cubed. So we have x cubed over 3 times natural logarithm of x minus the integral of v, which is now x cubed over 3 times u times du dx. What is du dx? Du dx right here, it is 1 over x by dx. So this is going to be x cubed over 3 natural logarithm of x minus the integral of x squared over 3 by dx. Okay, if you want, you can pull out a third. If you want, just move on and integrate, as long as you know what you are doing. So this is going to be x cubed over 3 natural logarithm of x minus x cubed over 9 plus a constant of integration. So ladies and gentlemen, we have been able to integrate this by making use of the formula. Which formula have we made use of? It is this formula, okay, which integrates a product, and that's what we call integration by parts. We shall see why it is called integration by parts. In some situations, you may need to pick a part of the integral as you are progressing to find a solution. At some point, you pick part of the integral and also look at it as integration by parts. So we shall see that's coming ahead in example, this example 1. So in example 2 and 3 or 4, whatever, I will give you a variety of examples so you don't have to struggle with this area. It's really so cheap. Okay, so therefore integral of x squared natural logarithm of x by dx is x cubed over 3. Okay, natural logarithm of x minus x cubed over 9 plus a constant of integration, and we are done. So in this formula, integral u dv by dx with respect to x being equal to uv minus the integral v du by dx with respect to x, okay? It is always important for you to understand which function, okay, or to know which function we call u, okay, and then the other function will be dv by dx, because they will always give you a product of two functions of x, okay? So if you know which function to call u, then the integral becomes so easy for you. Some situations are really challenging. You may fail to pick a u and you may fail to pick a dv by dx. So let's write down something that will guide you in the future how to select u and how to select dv by dx. So we put here priority order for u, which function to call u and which function to call dv dx. So this will always guide you on what factor to call u, okay? If one factor is a log function, that must be taken as u, okay? So if you have a log function, what do you mean by log function? A log function is, in this case, natural logarithm of whatever, of a function of x. So if one of the factors is natural logarithm, use natural logarithm as one of the factors, then automatically that becomes your u. If there is no log function, but a power of x, that becomes u, okay? If you have some situation where you have x squared d sine of x and they want to integrate something like that by dx, okay? Then this automatically becomes u because there is no log function. So the power of x automatically is what we take as u. If there is neither a log function nor a power of x, the exponential function is taken as u, okay? So you could have a situation where you have integral e to power 2x sine of x by dx, okay? So in that case, the exponential function will be taken as u, okay? But even if you take sine, we anyway shall see that these are repeating functions, okay? But you could also have this situation, x squared d e to power 2x. In that case, there is a power of x. This cannot be u, okay? Automatically, the power of x becomes u. So, yeah, you remembering this priority order will save you a lot of false starts. So, it is important you master this part so that when you're confronted with a problem about integration by parts, you straightforward know what function to take as u and what function to take as dv by dx. All right. Let me write down a few examples so you can always refer to, okay, when you are selecting which function to call u. Okay, so look at this integral x power 4, okay, then cosine of 2x. In this case, u is x to power 4, okay, then integral of x to power 4 e to power 3x by dx. So u still is x to power 4, okay, integral of x squared d, natural logarithm of x plus a 4, there's something here, natural logarithm of x plus a 4, okay, so here u is natural logarithm of x plus a 4, and then integral e to power 2x cosine of 4x by dx. Oh, this is by dx. Even here there is a dx. Okay. And here u is e to power 2x. Okay. So it is easy for sure. As long as you know what to do, everything will always be easy. Now, let's try some more examples about integration by parts. All right. We begin with something that will stretch us somehow. Let's look at this. Integrate x cubed d, okay, cos 2x by dx. Okay. Remember, we have to use the formula, okay, the integral. Remember, we are to use the formula integral of u dv by dx with respect to x as uv minus the integral of v du by dx with respect to x. Okay, so in this case, we are going to let u to be equal to x cubed. So meaning that my du by dx is equal to 3x squared. Okay, let us see how it about this. So that means in this case, the v by dx is equal to cosine of 2x. Okay, the v is cosine of 2x by dx. Okay, integrate both sides. So v will be equal to, when we integrate a cosine, we get a sine of 2x. So differentiate that angle 2x and divide by that derivative, which is a 2. Okay, so now we feed in the formula and see what we end up with. Okay, so what does this mean? That the integral of x cubed times the cosine of 2x by dx will give us u times v. Remember, u is x cubed. Okay, times the sine of 2x over 2 minus the integral of v, which in this case is sine 2x over 2, okay, then by dx. No, there is a mistake still. So we have not substituted for du dx. Remember, du dx is a function which is 3x squared. This is 3x squared by dx. So in that case, we are still moving on, looking at this as x cubed over 2 sine of 2x, okay, minus 3 over 2 integral of x squared times sine of 2x by dx. Okay, now this part, why do we call this integration by parts? This part is going to be considered as another integral by parts, you know, where you have to use a product to integrate it. So we have to consider integral of x squared sine of 2x by dx, and let u equals to x squared, meaning that du by dx is equal to 2x. Then the v by dx is the sine of 2x. Okay, so what does it mean? Then that v is the integral of sine 2x by dx. But remember, when you differentiate a cosine, you get negative sign. So integrating a sine, you're going to get negative cosine. This is a minus cosine of 2x over 2. Always differentiate the angle and divide. Okay, now it is still stretching far. Okay, let us see. We have to integrate this part after we come back and substitute here. Okay, let's move on. So this means that the integral of x squared sine 2x is going to be minus x squared d, okay, cosine Remember, the integral of a sine is a cosine. So cosine of 2x over 2 minus the integral of a v, the v here is minus cosine of 2x over 2 times du dx, and du dx is 2x, okay, by dx. So it is still a long way, ladies and gentlemen, okay? So what do? We shall make a back substitution at once, but let us go ahead and finish looking at this part, and then after we have done with it, then we make a back substitution. But this simplified further. Let's simplify it. This is equal to x squared, it's a negative x squared d cosine of 2x over 2, okay, minus, to now a plus, the integral of x times the cos 2x by dx, okay? Now, still there is another part here. Again, this is going to be considered as an integral by part. Remember, what we are looking at is going to be back substituted, okay? So, consider integral of x times cos 2x by dx. Let u equals to x, meaning that du by dx is equal to 1. Then dv by dx is the cosine of 2x. The good thing, we have integrated this before, so v is going to be a sine 2x over 2. Now the integral of x times the cosine of 2x by dx will be uv. Remember, the formula is uv. So my u here is x, and the v is sine. So it is x sine 2x over 2, then minus the integral of v, which is now a sine 2x over 2 times du dx. In this case, we allocate is equal to 1 by dx. So this finally comes to x sine 2x over 2 minus, okay, when you integrate a sine, you get, negative cosine. So this is going to be plus the cosine of 2x over 4, okay, and then plus, we shall add a constant of integration after, consolidating everything, bring everything together. Let's not add a constant of integration right now, but will be added in the last stage, okay? So this part, we get this and the substitute, okay, get this part here and substitute right here. What does it mean? Okay, this means that this means that my integral of x squared sine 2x by dx is now equal to minus x squared cosine of 2x over 2, okay, plus x sine 2x over 2, then plus cosine of 2x over 4. So far, that's where we are. But remember, this is a part that came from somewhere, and we have to go back and substitute for it, okay? What was the original integral? The original integral is x cubed plus 2x by dx, and this, so far, it has taken us to a step where we have x cubed over 2 sine of 2x, then minus 3 over 2, now into minus x squared over 2 cos 2x plus x sine 2x over 2, then plus cos 2x over 4, okay? So far, that's where we are, okay? The rest is now simplifying and then adding a constant of integration, and we shall be done. Okay, let's write this real quick and finish up with this integral. And then I tell you about a shorter method of coming up with the same result. You know, it is always good to go through something, then you'll always appreciate that there's a short way of doing it. If I had begun with a short way of doing it, then you'll become very lazy and you'll not discover this. So we are looking at the integral of x cubed cos of 2x by dx, taking us to x cubed over 2 sine 2x, okay, minus a 3 over 2 into. So let's write this so well and we see whether it agrees what we're going to come up with. So this is going to be x cubed over 2 sine of 2x, okay, plus 3x squared over 4 cosine of 2x, okay, minus x sine 2x over 4, okay, I think that's going to be 3x sine 2x over 4, then minus 3 cos 2x over 8, then plus a constant of integration, okay, and that's what we are having. That's our result for this integral. It's really a long way, you know, very painful. If you're not so strong, you may give up on the way. But let's check on this. There is always a shorter method, and this method apply it whenever u is equal to a power of x that is more than 2. Okay, if the power of x goes beyond the 2, okay, you can use a very short method. What is this method? Okay, this method tells us that to integrate this function here, okay, u is what we call the derivative. So we have derivative and then the integral, okay, the integral is the dv by dx. So we are picking x cubed as u, and we are looking at the cosine of 2x as our dv by dx, okay. So differentiate, you have 3x squared, integrate a cosine, okay. So that's why it is important for you to know what do you get when integrate cosine. When integrate cosine, I end up with a positive sign of the angle 2x, but I differentiate the angle and I divide by that derivative. Okay, integrate here, you'll have 6x, okay. Differentiate, we're going to get negative cosine of 2x over 4, okay. Yeah, differentiate, you come up with a 6, okay. Integrate, you're going to get negative sine of 2x over 8, okay. Differentiate, you differentiate till you get 0. Differentiate, you get 0. Integrate here, okay, you end up with a cosine of 2x over 16. Okay, so what's the implication? We match this variable, this diagonally goes with that, this goes with this, this goes with this, and this last one goes with that, okay. So what we do, we multiply through and see what we shall end up with, okay. So this gives us the integral, so it will give us the integral of x cubed cosine of 2x by dx equals, let's write these products, but remember there is also another rule. The first one is positive, the second is negative. Positive, negative, okay. Let's see, this first product is x cubed over 2 sine of 2x, okay. Then let's go to the next product. We are multiplying 3x and minus, so it's minus 3x and it is going to be a plus. plus 3 x squared cos 2x over 4. Okay, the third is a plus, so you multiply 6x by, okay, 6x, 6 cancels with 8 and you have 3 and a 4. Okay, so minus 3x sine 2x over, it's going to be a 4. Okay, then the last one is minus 6 and a 16 by 2. Okay, is 3. Okay, cos 2x over 8. Then last plus a constant of integration. Okay, this answer we are getting here, this answer we have just gotten here for this result, okay, is the same as what we have here. And we have used a very short time to get, the same thing. So, do this whenever the power of x, okay, is what we are calling you, and that power of x is exceeding 2. Go to the table, you will have the answer very fast. So the method is so useful and we can always make use of it. Let's check this example and see how we can use that method to solve it so quick. We are required to integrate x power 4 e to power 3x by dx. Remember, if there is an x power, that becomes u. So my derivative is the u, then the integral is the dv by dx. Okay, so I want to come up with a table so quick and I avoid going through the lengthy process of integrating the different parts. So this is x power 4 and this is e to power 3x. So differentiate, okay, 4x cubed, integrate, okay, this will be e to power 3x over 3, differentiate 12x squared, okay, integrate e to power 3x over 9, differentiate, this is going to be 24x, okay, integrate e 3x over 27, differentiate 24, integrate e to power 3x out of 27 by 3 is something like 81. Okay, 3 times plus the 2 is 81. Then lastly 0, and this is e to power 3x all over multiplied by 3 is 243. Okay, so the space down was so small, but I think you'll be able to see the integral of x power 4 e to power 3x by dx will now give us, this is how we match the products. This goes diagonally, that goes with, okay, this part goes with this, then this goes with this part, then lastly this will go here, and this is positive, negative, positive, negative, positive. So the first one is going to be x power 4 over 3 e power 3x. Okay, then the second will be minus 4x cubed, okay, e to power 3x out of 9. Okay, then it will be a plus 12x squared e to power 3x out of 27, then minus 24x e to power 3x over, this is going to be 81. Okay, then lastly plus a 24, okay, e to power 3x out of 243, then plus a constant, and that's it. We have integrated the function so fast using this table. Okay, now One more example, then I think after you can do it on your own. So this is gonna be our last example today, and we want to talk about this repeating function is integrate e to power 5x, then sine 3x by dx. Okay, so we say that if there is an exponential function, that automatically becomes u. So I let my u equals to e to power 3x. That means that du by dx is 3 e to power 3x. Okay, then dv by dx is sine 3x. Okay, if we integrate, dv will be equal to sine 3x by dx. Go ahead and integrate both sides, and you end up with v equals to, when integrate, you get negative cosine 3x out of 3. Okay, so we feed in the formula, and so it will give us the integral of e to power 3x sine 3x by dx equals, remember the formula is integral of u in change, so you can see the formula clearly. The formula we use, we have derived it. It is integral of u dv by dx is uv minus integral v du by dx with respect to x. So our u is e to power 3x, and the v dx has given us v as minus cos 3x over 3. So we want to integrate this. We're going to have uv. This is minus e to power 3x cos of 3x out of 3, then minus the integral of a v, okay, times du dx, which is 3 e to power 3x. Then this is going to be a plus because my v is a negative, so it is a plus. You know why it is a plus, because v is negative, and therefore it changes this part and makes it a positive, just to simplify life. So this is cos 3x, okay, over 3 by dx. And what happens here, when you notice here, so well, if you organize your work, you're going to have minus e to power 3x cos 3x over 3 plus the integral of e to power 3x cos of 3x by dx. Now we look at this as another part. Consider the integral of e to power 3x cos of 3x by dx. What happens is we let our u equals to e to power 3x, and that will mean that du by dx is 3 e to power 3x. Then my v, dv by dx is cosine of 3x. If you integrate a cosine, v will be equal to sine 3x out of 3. Okay, so the integral of e to power 3x cos 3x gives us uv. Substitute, u is e to power 3x, and v is sine 3x out of 3 minus the integral of v du dx. But look at du dx, it is 3e to power 3x. Then v is sine 3x out of 3, then by dx. So the 3 cancels out, okay, and then we end up with this. Now pick the whole integral. So what does it mean? This means that if you come back to this stage and pick the whole integral, the integral of e to power 3x sine of 3x by dx, okay, so far it is minus e to power 3x cos 3x over 3, now plus e to power 3x sine of 3x out of 3 and minus the integral of e to power 3x sine 3x by dx. Let's write this so on the other side so it is clear to everybody. So, ladies and gentlemen, that's what we get out of this integral. But something you have to notice that after some particular steps, such types of integrals do repeat. Okay, if you look at this part, if you want to see what I'm talking about, this part and this part are the same. Okay, now let I equals to the integral of e power 3x sine of 3x by dx. So I'll have I here is minus e to power 3x cos of 3x over 3 plus e to power 3x sine 3x over 3, then minus I. So let's correct like terms. We have 2I is equal to e to power 3x out of 3 into sine 3x minus cosine of 3x, okay, plus some constant, or my I is equal to e to power 3x over 3 into sine 3x minus cos 3x, then plus the c. Okay, so these are your questions. Try them out and test your understanding about integration by parts. Ladies and gentlemen, we are moving on. This is our 5th lesson and we are done with integration by parts. What we are left with is trying out a variety of questions from the different parts. Remember, the books I'm using Pure Mathematics by Backhouse 1 and 2. I'm using Pure Mathematics by Tranter. I'm using Engineering Mathematics by K.S. Prod. And I'm using Further Elementary Analysis by J. Potter. So there are so many books. Look for questions, work out numbers, stop complaining.